go through and do a footing layout. So making sure we're on the footing layer property, I'm using a green line because I've already got red, yellow, pink and white, everything else in here. So I draw a polyline. Now our footings, or our slab, comes the whole way to the edge of our brick. So our brick will sit on that concrete. It sits in the rebate, but it's still part of the concrete. So drawing to the edge of our building, so right around the outside of it. And then close. So grab that outside line and let's move it across by a known quantity. So let's say 20,000. Cool. So this is my outside line, which is the boundary. So offset, my footings are all 300 millimeters in width, as we saw previously. So what happens is I know this is my outside line, so my footings sit inside of that. Cool. So this gets my perimeter footings. Now what I need to do is I need to put in my continuity, which is a big thing. Everything has to run into a grid. If we get this wrong, that's when buildings start to crack. And the purpose of these foundations is ruined. So straight away, all of my corners, I just make straight lines right the way to the edge. Cool, and these line up. And then straight across. And then this one here straight across as well. Awesome. So now offset by 300, kind of like our studs, these have to be continuous. Alright, sorry about my dog barking. I don't know what she's trying to kill, but she's going to kill something. Awesome. So that's our starting point. These are all of our boundary conditions. We do the outside because that's fixed, and we put our continuity in because we have to. We haven't got a choice. And now this is where we start to optimize and things get a bit trickier. So what I'm going to do is measure. Remember, I've got 4 meters maximum center to center spacing. So from here to here is 5850. If I plus 300 to that, which would get me the center to center spacing, I'm at 6150. So what I need to do is draw a line and put another footing right in the middle. So I snap the midpoint and come straight across to there. Offset now by 150. One up, one down. I can delete that center line. So that puts one right in the middle. Cool. So I know this spacing here, so going in the X direction is okay. Now what about the Y direction? So let's check here to here. 3190, so that's okay. So center to center is what, 3490? What about this one? Oh, so 3950. So I'm going to get 4250 from the center of this one to the center of this one. So that's too big. Now this is where when you come into geotechnical engineering, you'll be studying the standards and going through, but for now you have to take my word for it. That 4 meter center to center is for the first footing from an external. Okay, so from this way and from this way. So this direction, this is okay. This direction is too wide. But in the X direction, this footing here isn't the edge footing. So part of the standards is what it does is it lets us, if this footing here is less than 4 meters, which is the first one, we can make up 25% spacing in between. So what that means basically is this one's alright. We can get away with it. So we will leave this one here. This one here, same thing, it's okay. Let's check this one up here. It's the first footing coming in. and it is too big. Okay, from center to center is more than 4 meters, which means we have to put one in the middle. So deemed to comply, we have to do this. If we were to do it on software, we would probably get away with it and we wouldn't have to. But for the standards, we don't have a choice. It costs a bit more. Again, it's conservative, but that's okay. So we delete this one. We've got a stupid, annoying footing there, but that's all right, we haven't got a choice. Now, let's copy these. Copy. First footing in has to be 4 meters. Okay, and now what I may as well do, if this one's 4, may as well come down to another 8, just to try get these spacings and see where they're at. So let's have a look, let's check. Here to here is 3.7, so center to center is 4, which means this one's okay. So I can check it, there to there, cool. So center to center will be 4 as well. Now what about this one? So from here to here, it's 3.4, awesome. Now these can't stop here, they have to run the whole way through. So extend, extending to this line, enter. What am I extending? Well, let's extend these. Cool. Now what about here? Here to here, it's 3.95. So this one here, I have an issue. This spacing here is too wide. So I'm gonna have to put a footing in here. It might be okay here, but here I'll have to put one. So let's put in a footing. Part of the standard is we can just come to here and put one into this grid, but yeah, I'm not really a big fan of it. Okay, for numerous reasons, which you'll discover when you study next semester, it's better to continue it the whole way through. It costs a bit more, but for the long-term effects, it's much better. So let's put one here and one here, and delete that one. All right. So that pretty much concludes our footing outline. Now let's come through and select all of the internal lines. Okay, so this external line we will see. If we look at our slab, we see this. We don't see these, there's concrete over them. So what do we do with any kind of beams or lines that we can't see? Well, we make them dashed. Alright, and the next thing is they're just like our timber studs. So we get to trim them all, enter, and this is where my therapy starts. And I get to just trim everything up, and it's just, I don't know, it's quite nice and therapeutic. So let's come through, because everything's continuous. The hatching will adjust as we go. Cool, let's come through here as well. Alright, and then this should be the last one. Oh, no, I've missed one. Just having a quick check, because I didn't really do that in the smartest method ever. But still, I'm quite happy because it looks very nice. All symmetrical. So that's our footings and how they're sitting. The next thing we have to do is we have to worry about our re-entrant corners and we have to worry about our set downs. So which one would you guys like to tackle first? Well, because no one else is here talking to me, I'm going to go for the re-entrant bars first. So let's draw a line. Green's okay. So let's click anywhere here and we're going to draw a straight line. Now part of our re-entrant corners is, I've just noticed I've missed these trimmings. So I'm going to get these before I do anything else. Alright, and now I'm happy. Was happy before, but now I'm ecstatic. So, line. What these re-entrant bars are these are 3 N12s that are 2 meters long. We know that, it says it in the standards. So 2 meters is 2000 millimeters. I'm going to rotate these at 45 degrees. I'm going to offset by 50 millimeters. One way, one the other way. Okay. So what these are for is these are for our crack control. Okay, for our torsion and things like that that happen as our ground moves. So what do we do with them? Well, we copy them. And we're just going to place them. So I'm going to turn off my ortho. We're just going to place them here. So this beam comes in and then goes, nah, I'm not coming inside anymore, I'm going this way. So this here is a reentrant corner. This here is a reentrant corner. I have another one here, but it has to be these. So the whole point of steel, when it comes to cracking of concrete, is the steel has to cut through where the crack's going to happen. So these have to sit there. So these are our reentrant bars. Alright, we'll label them in a minute. But this is them. So I can now delete these. So these are 3 N12s that are 2 meters for our reentrant corners. Now what I need to do is put in my set downs. So this is my floor plan. What am I setting down? Well, if I had an alfresco out here, I would set it down. If I had a porch at the front here, I would set it down and put strip footings in. You'll learn that when you do geotechnical engineering. But for now, all we know is we have these wet areas and a garage. So I'm going to set down here, which is the inside of the wall. So the walls will sit on the higher side. Okay, so I'm just going to draw through my wet areas first. So what happens is if this, if this shower floods, we make this concrete inside sit lower than the rest of the house. So it gives us time. If it's flooding in here, the water's not going to come through, which means we sit the walls on the higher side. So the set down is 50 millimeters typically. There can be more, but generally it's a 50 millimeter set down. And the other one is the garage. So let's set down the garage to here. So now what I'm going to do? Well, let's select them all. Select down the green boxes, which we've just drawn to set down. Now I've got two options. I can copy or move. So I'm going to move. This corner here is this corner here from the brick. So I can set my reference to here and move them across. Or what I can do is I know straight line, so ortho on, is I know firstly that when I moved my footings out, I moved them by 20,000. So now these green boxes here is where these wet areas are. So I draw a line from corner to corner on all of them. So these are the areas to be set down. So now let's write a bit of text in there as well. So draw over here, text, SD, move. So put that there. Copy. Let's grab from the midpoint of this one. I'm just going to put them, space them around so I can actually see them when I'm looking at the plan. It's a bit too close to the line. So then it becomes an aesthetic kind of thing. Okay. We'll also just put a note down here. SD. notes area to be set down. Cool. Awesome. So now that we've got them in there, what else are we going to do? Well, I've got to label these somehow. So let's label these. Annotate. I'm going to use a multi-leader, which basically gives me an arrow and a line. So let's come from this one. My ortho's on, so let's just turn that off for a second and come here. So this here is my 3 and 12 at re-entrant corners. Re-entrant corner. Cool. Alright, so I've got that one there. Now this arrow is a bit stupid. Okay, if I zoom right in I can see it, but if not I can't. How do I change that? Well, let's change up the properties. So arrowhead, let's try 100, see how that looks. No, not big enough. Let's try 200. Bit better. Okay. Probably make it a bit bigger. Let's do it. 250. Yeah, that will do. And now this one, copy, and I have this here. I've also got one here. I can't have writing in my drawing, so I might put this down here, and then I might just tuck this up a bit. Okay, so that's one way you can do it. The other way you could do it is get rid of these, basically put this into a legend and just write next to it that these here, this symbolizes the 3 and 12s at re-entrant corners. Alright, but that's pretty much how we do a footing layout. Alright, you will learn more of that in your geotechnical engineering, as I've mentioned about 1,000 times so far. So please make sure you understand how to do this. And I will show you in the next video how to do a typical cross section. Thanks guys.